Hey, good morning, everyone. Thank you so much for joining in for today's session. As an introduction, my name is Muneeb. I'm from Bangalore, and I'm a design verification staff engineer. And I have 7 years plus of experience in design verification. And I have an amazing experience in IP verification, subsystem verification, and SOC level verification. For SOC level, I have worked specifically on open source computer architecture like RISC-V, and I have a very special interest in computer architecture and open source as well. Apart from my technical domain, my interest lies in playing guitar, performing card magic, and reading novels, specifically on the thriller genre. So once again, thank you so much, everybody, for joining in. So let's start today's session with some introduction.
Sure, yeah. This is Venkatesh. So I have completed my BE from New Horizon College of Engineering. And then I have completed my internship in CM Semiconductors, followed by joined Mirafra Technologies as a design verification engineer, right? And currently I have 1 year experience working on the client location
Mhm,
from Mirafra.
mhm.
So yeah, my um, uh, personal hobbies are like traveling, music kind of things. Right? So yeah, that's it. Thanks.
Thank you so much for that introduction and for joining in, Venkatesh. Appreciate it.
Thank you. Thank you. Thank you, Mani.
Okay. So, before we get into this session, I just wanted to tell what's the purpose of me starting, these kind of live sessions. So I graduated in 2013, and it took me almost 1.5 year to get into this industry. And today I have 7+ years of experience in design verification. But the start was a little challenging. And hence I wanted to make it much more easier for people who are interested to get into this DV field without having to waste so much of time. Now, since I spent a lot more time, doing my trial and errors to get into the industry, and even in the industry, experimenting with a lot of concepts, working on different variety of topics, I want to share all of that knowledge with you guys so that the work or the experience that I've gained in 7 years, I can just pack them and give it to you, maybe perhaps in a very less time. And the third thing is that we always try to search for questions on Google or Quora, but then we do have some specific question which doesn't get answered. So we have to read 2 or 3 questions, figure out the answers and correlate them to make sense out of it. So, but we don't know whether it is right or wrong, but we're making the connection. So this is where I would like to take the opportunity to kind of have a session where I can answer your SystemVerilog questions as and when you're going to have it. So that is what is going to be more interesting. Yeah, people who could not join in, we can, I'll always upload these videos where they can view it. But the advantage of joining in is that you can ask your specific questions that you have and it'll get answered. Okay, so having said the introduction and the purpose of this meeting, I'm gonna try to say one more thing is that this I'm conducting on a Zoom app, and it's a free app, right? But it does have 40 minutes as the limit. So after 40 minutes, it will get disconnected. So all you have to do is rejoin with the same link. Okay, so that's for FYI. Now, coming from there, what I would like to show you a few things is there is a WhatsApp link wherein I'm going to do the announcements. So just wanted to take a poll that are you both aware of it and have you guys joined into that WhatsApp group?
Yes, sir.
Okay, cool.
Yeah, we are in.
Okay, awesome. So that's good. The other thing which I want to show, so what I would do is I'll share my screen. So first things first is that I would like you guys to create a GitHub account for yourself. And I'm gonna share this SystemVerilog course link onto the WhatsApp channel so you can access it. Okay, so just walking you guys through a little bit about it. Now, this is a SystemVerilog course that we have created, wherein we have the few contributors to it, and we have everything into it, almost most of the stuffs. So let's say if you're interested to walk through, let's say loops, you want to study loops. So they have different types of loops you can click on. one of the ones. Let's say you wanted to go into the for loop. So there is a code for for loop. How do you run it? And then we have run it on a simulation as well, so you can see the log file. But let's say that you're more interested in doing the EDA playground. So all you can do is just click on it. You can copy paste this whole thing, put it into the EDA playground and run it. Okay, so this is one part of it. Now the other is that once you come here, there's a read which talks about, there's a detailed documentation that we have and the LRM as well. So this is the LRM that I have, which is a very updated version. Also, this is something which I want to talk to you about. It's called a wiki page. So when you click on it, it's still in the SystemVerilog course section, but it's in the wiki section of it. And on the right hand side, you can see there's a lot of sections, just like it's a table of content. So let's say we were talking about loops, right? So one of the things that you could also do is search here as well. So let's say you search for it, it can show you a lot more sections. So let's say, so it'll show you the loops. Let's say we go to the for loop. And here, if you see the sections, so we have repeat statements, we have whiles, do while, and for loop. So this is where you land. And here there's a lot of content to it where it says about what's a for loop, what's initializations with an example. They try to explain more about how do you start, what's a condition, what's an output to. And not only that, we do have link which will take you to the code that I showed it to you, and also to the output file as a log file too. So this is where you can experiment and work through it. So let's say that now we have all of code here, you can go through, and then let's say you have a question, and that question you're not able to answer it, or you searched on it but you're not convinced. There is this discussion section. So since I'm trying to have this online session, so having interaction would always be good. So Srinivas, I'm just trying to address you. Are you able to see this discussion section here?
Yes, sir.
Okay, so if you click on this discussion, it will open you a discussion portal. Now, let's say you have a certain question and answer that you want to ask, right? So you can just click on this question and answer, okay? And onto this, you can say a new discussion. And then you can just type in your question. So let's say, what is the difference between, say, $rose and posage? Okay, so once you write a question, you can just write a question, ask for help, or if you know an answer, you can just mention the answer, and then we'll have reviewers who'll review the code or review the answer to it and then say it's right or wrong, or maybe even add our section to it. Okay, and then you have a lot more sections. For example, there's this code. So let's say you want to add some code to it. You can do a triple backtick and write it inside it. So let's say for int x equals to 0, x less than 10, and x plus plus begin. Okay, and then let's say y is equal to y plus 1, end. So I'll just show it in the preview. Whatever you've written would be in this kind of a gray box, and then it will be much more neater for somebody to understand what you're trying to explain in this section. So you can make use of this. So there's a header where if you want to write a small heading, you can possibly use. So if you click on this header and then say writing header line, it will be bold and it will be in a much more bigger font. So there's a bold section. Then there's bullets, there's numbering that you can add. You can even mention some people. Let's say, you can just write, at the rate, and then say, can you help me answer this question? Something of that sort. And we do have referencing an issue, which we will talk later, but you can connect one discussion with another discussion as well. So once you have done that, you can actually do something called start discussion. But before than that, do you see a labels on the right hand side?
Yes, sir.
Okay, so now if you click on this label, I have created multiple labels to this. Okay, now there's section 1, 2, 3, so on and so forth, up to I guess till 40. Now, what does this mean? This is in line with the SystemVerilog's LRM topics. So if you take a SystemVerilog LRM, there are 40 topics that we have. And the reason I want you guys to label your question is twofold. First, it will help you understand what is the topic that you're trying to ask a question in. And second, we will always be able to attach that question to a label or a topic in SystemVerilog as a LRM. It'll be easier for us to always go and go through the LRM in more detail also going further. So now, since this is related to an assertion, I'm going to click assertion. This is an API. So I need to search for assertion. So I can even search here. I can just say assertions and then click on it. So this is how the labels you would have. You can write your question and this. Now, writing a label would really help if you know it. If you don't know it, you can leave it blank and the reviewers would add it. And you can just create a discussion. Okay, so this is how a discussion would be created, and then people would answer your questions and so on and so forth, and then we'll have everything at one place. So it could be related to the question that you're having, it could be some kind of interview questions that you went through and you're not able to answer, or maybe something that you like to share with other people as well. Okay, so this is something that I wanted to talk about with regards to the SystemVerilog course, the wiki page, the discussions, the labels and question answers. Okay, now having said that, maybe we can just start with our whatever the session we had, right? So let's maybe start with Srinivasa. Like, if you have any questions, maybe let's just start with one question of yours. Let's see if we can be able to help you out there.
Can you tell me this question only, sir? What is the difference between the rows and projects?
Okay. So, the first question that you're asking about is what's the difference between a $ rows and a posage, right? So let's start with your understanding. Okay. What do you understand when somebody says $ rows?
Is rising edge like 0 to 1. That's called
Okay.
as.
So this is basically a 0 to 1. Okay. Which we talk about $ rows. And what do you mean by a posage?
High level signal.
Okay. A high level, but again, it's still an edge. So it's again a transition from 0 to 1, right? So whenever
Yes.
we say, for example, let's say we say at the rate of pos edge of, let's say this is my signal called clock, right? So this is the point at which this will get triggered. Agreed?
Yes, sir.
Okay. So now $ rows also a transition. So if you really see this section, both are identical, right? There's a transition on both the sides. But what exactly is the difference? Now, $rows is a system function. Okay. Now, what does that mean? A function will always, most likely will return you a value, right? So this will return you a value either true or false. Okay. Now, so let's say if you're trying to do $rows of clock, because we are trying to refer a clock here, $rows is trying to take an input as a clock, and it's gonna return you true or false. So whenever there's a transition from 0 to 1, it is gonna say that it is gonna be true. So it is gonna return you true. So you can say that $rows is a system function to return you either true or false. The posage, on the other hand, it's not a function, it's like an event, right? It's getting triggered at a particular point. And that is the major difference between the two. So whenever we are trying to use certain events, let's say at the rate of posage, you are trying to wait until a posage is going to occur on a clock. So let's say if this is my timestamp at which I am, this event will basically be blocking until the pause edge comes. However, a $ rows is something where basically it is gonna just check that did the value change from 0 to 1. If it does, it is going to return you true, else false. So it's not at all blocking. It is basically going to check at that instance, is there a transition? So it's a system function, and this is an event. Okay.
Okay, sir. Thank you.
Okay, cool. Now, for the other people who have recently joined in, I just want to give you a heads up that within 2.5 minutes, the Zoom session will close because it's a free session of 40 minutes. It's the limit that it has. So all I would request is join back with the same link. Okay, cool. So that's the first question that we had from Srinivasa. Okay, and since there are a few other people, I'll love to go in a round robin fashion. A round robin is an arbitration scheme wherein you go in a round fashion. Now say here there are like 5 to 6 participants, so you're gonna go one at a time in loop and then again go back so that everybody gets a chance. Okay, so maybe let's try to talk with another person, perhaps.
Hey, hi, Manik.
Yes.
I have actually one question.
Mm-hmm.
But can I take up any like related to not one particular topic, right? Can I take up any topic as well, right? Like
Let's
related to
give it a
folk
try.
joints or kind of anything.
Let's give it a try.
Yeah. Yeah. I mean, like I don't have like kind of direct question,
Mm-hmm.
but while I was trying some code in EDA,
Mm-hmm.
right?
Mm-hmm.
So I was experiencing kind of different output there related to folk join none.
Mm-hmm.
So with using automatic variable in that,
Mm-hmm.
right?
Mm-hmm.
So just trying to, I don't know how can I show that code here because I don't have code currently with me.
Okay.
But as of now, at least I wanted to understand the keyword automatic, how it works,
Okay.
and then the
Okay. Got it.
ref keyword as well. So those
Sure.
two I get confused between like little bit much on that, right?
Got it.
So, but
And
maybe
very quick,
perhaps
right?
after some next week or like that, I can get up the code as well, like that for you, right?
Sure. So now, since you don't have the code, possibly we can take a look. Now, you're asking for automatic keyword in perhaps a fork join, right?
Yeah, yes, money.
Okay. Let's see if we
Because I was
can.
expecting some other behavior with respect to Folkjan. Any or Folkjan is very different output compared to Folkjan none.
Mm-hmm.
So
Okay.
I was trying to understand. Yeah, yeah, you can take up this code itself, right? I have tried same code itself, kind of.
Okay. Okay.
So at least not at least module automatic,
Mm-hmm.
but only the variable he has used, right? In int k.
Mm-hmm.
So that was my kind of usage.
Okay.
So
So if I
I was
understand your
trying to
question
expect
right,
some,
you're trying
yeah,
to understand the keyword automatic in this scenario of
correct.
join none.
Correct, correct, yeah.
Okay, cool. So possibly this could make a better case for us to understand, right? So there are a few things
Yeah.
that we have. So what they're trying to do, there is a fork join none. Okay,
Mm-hmm.
and then there's a for loop too. Okay, now the for loop does not have a begin and end, which means that if you don't have a begin and end for a for loop, only one statement can belong to
One,
it, right? Which means
correct.
here is the fork. Now my recommendation will always be for people is to make sure there's always a begin end so that you avoid the
Mm-hmm.
confusion. Okay, but anyways, having said that, this for loop has
Mm-hmm.
one fork, and this fork has multiple threads, right? This
Multiple
fork is
things, correct.
basically starting things in parallel. So one of the
Correct.
thread that we have is $send of k, right?
Mm-hmm.
So now there is an explanation too. Okay, let's try to first go through the explanation. Let's see what they do say it and what's our view. So it says the thing to know here is that automatic variables have a lifetime based on activation scope. Okay, They are
Sure.
created and initialized when entering that scope and disappears when leaving that scope. The key thing to know is that the scope remains active until reaching the procedure end of that scope and after all child processes have completed wherever comes last. So going one section at a time, what's a scope? The scope is generally defined by begin and end. Okay. So since you have a variable called, let's say, k, it is limited only to a very small section, which is in this particular point. Okay, so the scope of k will be limited only to this begin and end. Okay, so that's called scoping concept. Now, cases 2 and 3 are essentially the same. The activation scope for K is in begin and end inside fork join. There are actually 3 activations for K, one for each processor forked off. None of these processors activate until all the parent initial processor reaches hash deload, which is after the for loop has reached its final thing. Okay, cool. So now let me just do this part of it. So in order to explain it to you, let me take a screenshot of this. So this is what we're trying to take a look at it, right? Now, let's understand. So let me kind of say this is a for loop that I have. And for this for loop, we basically have only one statement, which is a fork. Okay. Now, what are they trying to do? Let's try to understand the overall understanding of this particular section, right, Vantesh? So they are trying to create 3 threads, okay, which is, let's say, $ right. So this could be some particular, so whenever you say $ right, it's kind of a system task or a system function, right? Okay, but you can even call your own functions too, and you're sending some parameters to it. So in this case, basically all they want is to send 0, then $ right of 1 and $ right of 2. They want to create 3 parallel threads. So this is T1, T2, and T3 in parallel. This is what they want to achieve at the end of the day. Would you agree with me?
Yeah, correct.
Okay, so this is what they want to achieve. But the catch is here is that they want all of these things to start in parallel. Now, one of the
Correct.
ways that they could have done is they could have done using, say, a fork, then join none, and they could have written $ right of 0, $ right of 1, and $ right of 2. Right? This is easier, right? So what happened? These are the 3 threads that will start. But now imagine that you want to do that 100 times. That's not reusable, right? So now what can we do? What can we possibly do? So let's go stages by stages for you guys to really understand this. So this is first thing that you would do. Okay. Now, let's say you want to optimize this code. So what you do, okay, it's repeated in 3 times, right? So why don't I just put it into a for loop, right? So let's say I do
Correct.
for int j equals to 0, j less than 3, j plus plus. Since I'm a big believer of writing beginners, I'm going to write it in this way. And I say fork, okay? And then they have written a begin. And I'm gonna say, let's say I don't even have this, right? Don't need this. I can say $ right of j, join none, end. Correct? This is what we would do.
Yeah.
Okay. Now, this is an optimized code when compared to 2, right?
One doubt here.
Yes.
Just sorry to interrupt. Because see, basically it is in fork join now, right? So and they used begin and inside fork join, right? So that will be, I guess, one thread instead of 3 threads.
Yeah. So
I
this
feel
is one thread, right?
because
So this is T,
yeah.
thread T only. But what is happening is that since we are creating in a for loop, so how does a for loop work? So first the j is 0, okay, and the 0 is less than 3, right? So we're gonna initialize this, check if 0 is less than 3, it is true, execute these statements, right? And
Correct.
since these statements are fork join none, it is just saying that whatever is within this, just start it in parallel. There's only one thread. So even
Okay.
if you write
So,
it begin here, it does not really matter in this particular case, right? Because there's only one thread,
okay.
beginning.
One thread at the end.
Okay, fine. So this is what you would do. Now, what would
Mm-hmm.
really happen with this particular case if you try to execute this? Okay, the
Mm-hmm.
the way it is gonna work, it's gonna create three threads. It'll create
Mm-hmm.
$ write, okay,
Correct.
but with the final value of j. What is the final
J.
value of
Correct.
j here? 2
It will be 3. I mean, like, yeah,
when you
kind of, yeah.
enter it,
2.
right? So it is
Correct,
gonna
correct.
create three threads with
Since
the
it is not automatic, right? So
final
that's
value
where it
of
is.
j. Exactly. So now
Mm-hmm.
you would do the first stage wherein you just write it in this way. And then, as a beginner, you'd try to, okay, since I understand for loop and things like that, I would do the second stage. But the problem with that
Mm-hmm.
is that the value of j, which you would get it in this particular, would be the final value. Okay.
Correct.
And then
Correct.
you would be like wondering, okay, that was not what I wanted, right? You wanted to create, this is your requirement with 0, 1, and 2,
Mm-hmm.
but you got all as 2s. That's not what you want.
Mm-hmm.
So now that is where
Mm-hmm.
the concept of automatic comes into picture. Okay. So now what are you
Correct.
trying to do here? So this is our third stage of writing the code. Okay. Now in this third
Mm-hmm.
stage, what you're trying to do is that, okay, I did fork and I did an join none. Okay. And I have one thread. That is what I'm trying to do here also, right? It's the same thing.
Mm-hmm.
But since I
Correct.
know that the value of j is not getting updated for every instance of it, I'm going to use some keyword called automatic. Now, what exactly the word automatic keyword means? It means that the scope of it is very short and it can be used for us to, give it for the $ write. So now what we're trying to do here, again, with the for loop, with j equals 0, the 0 is less than 3, you'll enter into this, right? Now, why did I write begin and end here? Because this is one thread, but I don't want these two things
Mm-hmm.
to run in parallel, right? This is
Parallel. Correct.
one section. So whenever you want something to run sequentially, that's when you give begin and end.
Okay. Correct.
Okay. So now since I understand every single line here, I've given begin and end, and I've written this piece of code. Good. Now, what am I trying to
Mm-hmm.
do here? Let's understand. I'm taking the value of j and putting into this very local variable called k, and I'm creating it as
Correct.
automatic because the scope is going to be very limited to it, and it will be thrown
Mm.
out because what happened here with this thing, the scope of j was bigger. The scope of j was for the whole for. So what was happening is that the scope of j was available to me, and since it's a fork join none, it will be executed and started parallelly. So the value of j which goes to all thread would be the final value. So what we're trying to
Correct.
do is that we're trying to limit the scope. But if we limit the scope of j itself, then we will not be able to use it
Mm-hmm.
in this. So what they do
Mm-hmm.
is that you take the value of j, which has a higher scope, and put that value into the k, which has a local scope, with using the word called automatic. Right? Now they have done, you don't need this and this actually, right? You just define as k semicolon and k equals j. Okay. Now, when
Correct.
you
Yeah.
pass this value, the $write will have three different instances. So for the first time, it is gonna create $write of 0. And since it is join none, what does a join none means? It will just start the thread. I mean, it will just schedule the threads, but it will not execute it, right? So it will just schedule, come back again, and then it will go for j equals 1. So it will write $write. J is as 1, put it into the k, and then it will be 1. And then $write, same thing with 2. So these three threads will be started or scheduled in parallel, and then it will come and execute this line, $display test2. Once it executes this, or when it is starting to execute this, these three threads will also be executed. How does a fork join none? A fork join none will just schedule the threads in parallel, but will not start them until you execute a thread after the fork join none. So the thread after the fork join none is my display statement. So this is how the word automatic with the local scoping helps us to execute multiple threads in parallel using a for loop.
Yeah, Manoj. So just have one doubt here. So I got it this explanation, but if you try to use the automatic int k equals to 0, right? So just before the fork begin, we have right. Uh, so I just want to understand what happens in that case if you try that, right?
If you
Because
write this
it
one
won't be inside
before
fork
then this.
join. Yeah, correct. Yeah.
Okay. So now,
So
what is happening here? You are trying to tell that the k value is j or before than that, right? But now,
correct.
if you try to do that, why did we even use this automatic int case? Because we wanted the local scope for this thread,
Mm,
right?
mm,
And the scope we
correct.
wanted is within fork join none. But now if you try to use it above, that is automatic int k as equal to j. Now I haven't tried it, okay, but we can give it a try.
Correct.
From my understanding, it would be that we'll still be able to achieve only this result
Mm-hmm.
because the scope you're gonna
Mm.
make it higher, and that would
Okay,
not
so
work.
here just want to understand one thing. So like in the explanation we saw, right? So the parent thread is for loop here, right? So until the parent thread completes its overall execution, right? So the child thread won't start, I guess. That's what they're explaining, I guess, right? There. So when you see that way, right? So by the time it executes your for loop, J value will be 2, right? So now once that completes and it will start executing the child thread, which is fork jan, right? So that time the J value will be 2,
Correct.
right? So now when you assign the J value to K, I mean, so it the same when you try to display the both K and J, so the both should give the same like 2, 2, 2, 2, right? Based on that. So I just want to tell that way, like, so if you try to execute after the child parent thread completes, so it will be the same value will come for you, right? So, but if you, as per my understanding, so I'm trying like if you move that automatic keyword beyond that fork join, right? So now that is not part of your fork join none. So
That's right.
and whenever the for loop executes, as you said, the k will assign with a j value which is 0, 1, 2. Right.
Correct.
Now when you try to display that inside fork join none, and since that will executed after for loop, that means like your parent thread completes, and since it is an automatic, even when you try to display kj values, so your j value might be 2, 2, 2, 2, but your k value will be 0, 1, 2, I guess, right?
Yes, it will.
That's what.
So correct. So here, if you, let's say, if you try to display, let's say you've written there and you want to display. So the value of k will go from 0, 1, 2. Okay. And the value of j that you get displayed is 2 only. But now, as you rightly said, if you write this automatic int k above, that thread will be executed first, all of those. And once you come and execute this thread, the value of $ right is k, right?
Correct.
The value of k, the final value of k, which is 2, will be assigned even for them when you write all those
Correct.
threads itself. So that is what would happen. Okay, I have not tried the lab, but we can definitely give that a shot and give I try that lab. But from my understanding as well, which aligns with you, is that that's going to happen. So that is why we kind of limit the scope of that and then put it inside the fork join.
Correct.
Okay,
Yeah.
sure. But yeah, definitely, you know, if you get some time, you could kind of
Yeah.
create a thread, as I showed about discussions, and have each of
Sure,
those,
sure, man.
you know, experiments, so that, you know, somebody is interested could get to know about this.
Sure. Yeah.
Okay, sure.
Sure.
Awesome. Thank you
Thanks.
so much for that.
Sure.
Okay.
Thank you so much.
So we have, okay, so let's say Srinivasa had another question again. So, Srinivasa, what's your other question?
Yes, sir, how these automatic and static variables will act in a module and in a class?
Okay, so you're asking what does the keyword automatic and static work as in a module?
Yes, sir. Inside module, how it will work, and inside the class, how it will work.
Okay, so maybe this is what I can explain. So if you, so let's understand what is the keyword automatic and static for that case, right? Now, what does automatic means? Automatic basically means in terms of when you have a function or task or variable, they're gonna be separate copies. Okay, so let's say if you kind of have a variable called automatic and you call them twice, it's gonna have two separate memories for it. But on the other hand, static means there's only one memory. Okay, so let's say this is, if I try to create a pictorial representation of something, I can just say that I can have multiple variations for automatic, but static will have only one version of it. Okay, so now let's say that if I have a function, okay, let's say the name of the function is example, and then let's say it has some inputs. And here, if I say int x, do some operation, and then say end function, right? So now, let's say that, explicitly, I would call this as static function. You're with me till here?
Yes, sir.
Okay. So now let's say I'm calling this function, which is say example, and then pass some value. This is my function call, right? So if I call this function, it's static. And if I say x is equal to 2 here, whenever I call this, the memory for x will be allocated, and int is of 32-bit wide. So a 32-bit space will be created for x, and the value of 2 will be stored into this. Now, if I call this function again, what happens is that even though I have int x in this case, it will not be executed. I'll have no memory space because I'm saying that all the things that you define inside the function, you make them static, which means whenever I call this function, it is again accessing the same space called x. You getting it? Okay, that is the
Yes, sir.
basic thing about static. Automatic, on the other hand, will be different. So what is automatic? So let's say I copy paste this thing. Okay, so now here, if I make it as say automatic, now in this case, what would happen is that every time you do an example, it will create your 32-bit memory space for x. But next time when you call it, it says that it's automatic, it will create a separate space for x. So these are two different variations, right? Now, why this was important for us to understand, to answer your question, right? So your question is that when you say a module and then you say static or automatic, right? Automatic or static, when compared to classes, which is automatic or static. Is this your question?
Yes, sir.
Okay. Now, first thing you need to understand is that the module by default is static in nature. That
Static in
means anything that you define inside a module, whether it's a function or a task or variables, will all be static. Okay, so instead of telling everything to be static individually, I'll just make the module as static, so everything inside it becomes static. Now, if you want everything inside a module to be automatic, you will create this automatic keyword here and the name of the module, right? So if you want a module to be acting as static, you don't really have to do anything, right? You will just not write anything because it is static by default. On the other hand, classes by default are automatic in nature. Okay, what does that mean? Anything you define within a class, like the variables, data members, or functions or tasks, they're all automatic. Why? Why is this default? I understand. See, module is something that you're trying to instantiate and you're trying to create a hardware out of that. Would you agree?
Yes, sir. Yes, sir.
Okay, which means whenever you want to create an hardware, we want that to be static. We don't want to change, right? Like
Yes, sir.
we have an adder, subtractor, or even a sock chip. You want it to stay there, so that's when we can fabricate it, right? If something is not there, how will you fabricate it? So you want it to be static. You want it to be available on a hardware, and that is why the modules are defined, traditionally as static itself. Now, why are classes defined as automatic? Let's understand. See, the concept of classes was as a blueprint, right? You create a blueprint and create multiple objects out of that, right? Now, what are the objects are trying to do? Every time you create an object, it will have its own memory, right? If you
Yes,
do
sir.
object.new, it will create its own memory. And when you create another object, let's say obj, it will have its own memory as well. So we don't want two objects to have the same memories. We want everything to have different memories, and that is why they want it by default. Because the purpose itself of classes is to make sure they have multiple spaces individually. They have created automatic. So this is what the default cases. But if you think that you want something like module as static, so let's say you want to create module automatic and then the name. Now, tell me, do you think this module will be synthesizable?
No, sir.
Exactly. That is what, right? So this is just would be used for your simulation purpose, where every space inside this will have a separate memory. Now, on the other hand, if I write, let's say class, and let's say a static keyword and so on and so forth, do you think this is synthesizable?
No, sir.
No, that's a good answer, because classes are not synthesizable either. So when you say
Yes.
static, what are you trying to say? We are just saying that for every object that you have, that is obj1 and obj2, make sure they're accessing the same memory for that, right? Sometimes it's important. Sometimes, like select a Zoom call, right? We want everybody, this object is, let's say, it's you, Srinivasa, and there's another person called Venkatesh. But we want both of you to come and access the same Zoom call. So that's important, right? Otherwise, if we had this concept, each one is accessing their own Zoom call and will not be able to collaborate and contribute. So this is generally useful in those cases when we want the objects to contribute to the same memory. Now, of course, you can write static to each or variable or a task or function, but that would be cumbersome, right? If you have 10 functions and 100 of data members, writing static for each one is cumbersome. So what do? You just define the whole class to be static, so that everything inside that will become static, and I can access those elements from any object but to the same location. Does that answer your question?
Sir, yes.
Okay, awesome, cool. Thank you for that question. So maybe again we'll move back to Venkatesh. We'll take one more question from each one of you. So hey Venkatesh, you have any other question?
My question. Currently, I'm not getting anything right now.
Okay, fine. Cool, no problem. So, I do have one thing maybe before we wind up for today's session. Let's talk a little bit on signaling strength. So, what exactly it means, signal strength? So, just taking a pool. So, are you aware of this, Srinivasa? Signal strengths?
No, sir.
Okay. And what about you, Venkatesh?
Yeah, Manu. I mean, like not very depth kind of information we have. Like you mean like weak signal and strong signal, right? If
Okay.
that is wrong.
Okay. So, what do you mean when you
Like
say something
strong.
as weak and strong?
It's been a very long time I studied, but I'll try short. But I guess if it is strong means, um, strong signal in the sense it can take up. But I forgot actually in between.
Sure, no
I forgot.
problem.
Actually, I studied little. But
Okay. So I'll just brush it a little bit. Okay. Now, First, let's go from one thing at once, okay? Now, what is the use of logic? That we all know that the logic can be used either as a wire or a reg. So now, if you see, I've defined X and Y as logic. Now, since X is used on the left-hand side of an assigned statement, X will become as a wire, right? So now this, even though it was defined as logic, it is acting as wire. Great. And Y, since it's used in the procedural statements, like an initial, begin, end, this becomes a reg. You agree with me?
Yeah, man.
Yes.
Correct.
Right, good. So now we know that we can have a wire and reg. Okay. Now, one of the things which I have done here is that I have done multiple drivers. Okay. Now, one of the limitation of logic is that even though it can act as a wire, but if there are multiple drivers, so here X is a wire, which is of type logic, right? But since there are multiple drivers, that is here, this is one driver and this is a second driver. X is getting 0 and X is also getting Y. So since there are multiple drivers, the logic will fail. The logic cannot work. So this is another limitation of logic. The logic cannot be used as a wire if there are multiple drivers. Okay. So if I have to kind of, let's say, copy this page and then paste it here. So I'm going to rewrite this code. So in this case, I'm going to write it as Y and then I'm going to write it as wire X. Okay. So these are my multiple drivers. So now this makes a better code. And okay. So now logic Y we have, wire X we have. Now these we have multiple drivers. Good. So in the previous case, we will get an compiler issue saying that X is a logic and it has multiple drivers. So we have solved that problem and we have reduced, there'll be no issue here. But still, let's understand what is the value. So at time 0, the X is getting a value 0 and Y is 1 and the value of 1 is also getting assigned to X. So there are two values being driven to X, right? So now if I ask Srinivasa, what do you think the value of X would be?
I think X.
Okay, why do you think it's X?
Assign will execute at 0 simulation time, right? So wire getting two values.
Okay, so why are getting two values? So why would it become X?
Unknown, so it doesn't know which value to take.
Perfect. Which means that 0 and 1 both are driving and X has only one place to hold, right? It's a signal. It's a wire that it can either have a 0 strength or a 1 strength. So, but if you try to drive both, who will win will be, we don't know. That is based on actually your, fabrication, right? So let's say that when you fabricated the kind of material you used for, passing on 0 or 1, based on whoever wins will get the final value. So that is why we call it X. We don't know. There's no definite thing. That's a problem, right? That's definitely a problem. So now, what is signal strength? This, when you're trying to drive 0 and 1, they are of the same strength. Okay, let me repeat that. If you drive a 0 and a 1 of the same strength, then the value will be an X. So now, how do you reduce this conflict? There is this concept in your SystemVerilog. There's a different strengths to it. Okay, so now there are strength levels given to everything. So now, whenever you try to drive a 0, it basically means it's a strong 0. Okay, similarly, there's something called pull up 0, there is a weak 0, medium 0, small 0, high impedance 0. Okay, and then supply 0. So if I do assign, okay, and if I say X is equal to 0, this becomes a strong 0. That you need to understand. The strength name is itself is 0. So it's like, you're writing it as strong 0. But instead of strong 0, let's say I try to do something like weak 0. And then I do assign X is equal to Y. From the previous example, Y was 1 and this is actually a strong 1. Now, what do you think will the value be now?
1.
1, because from this strength level, see that the x is getting a value 0 and 1. This one has a strength level of 6 because this is for zeros, and there's another one, this is for ones. Same thing, right? So the strong one has a value of 6. So now this has a strength value of 6, and this 0, since it's a weak 0, which we told, it has a strength of 3. So now we know that out of 6 and 3, the value that's going to win is 1. So the value of x at the end of the day will be a logic 1 now. Making sense?
Yes, sir.
Right? So this is how you kind of resolve. So now you might think, okay, x is bad. Of course it's bad because we don't know what's going to be the value. So multiple drivers is a real concept. So if you kind of work on I2C protocol, you'll see how multiple drivers can drive the same signal, and there's a possibility of many people driving at the same time with different strengths. So you need to have a way to deal with that, and this is where the signal strengths works into picture. So whenever you try to drive two things of the same strength, so here the strength was 6 and 6, and since it does not know, the value will be x. Now let's say there's another question. If this is 0 and this is 0, both of strength is, same strength, what will be the value now? If I ask Srinivasa?
I think x.
No, see, the value is 0, the value is 0 again, correct? And the strength is
Okay,
same.
sir.
Since the strength is same, both will win. And since both are 0 itself, the value will be 0, right?
Okay,
Because
sir.
there's
Correct.
no competition, right?
Competition. Yes,
There's no
yes, yes.
competition as such for him to win. So that is why whenever you get an X in your simulations, you need to think why. Because X
Different.
can have for two reasons, right? The value
Yes,
of
sir.
X can come from two reasons. One is that it's the default value for reg, correct? And
Yes,
X
sir.
can come if there are multiple drivers for a wire. So you need to understand, very important. So, don't just say that the value of X is only for reg. The value of X can be even for a wire, provided there are multiple drivers. And in multiple drivers also, they should be of the same strength. If they are of different strength, the person with the highest strength is going to win. So let's say, again, I give another example. X with a value 0, but the strength as 3. X with the value 0 with the strength of 6. Who's going to win?
6. And
Exactly. Exactly. So it's going to win with the strength of 6 with a value 0. So it's going to be a strong 0. So this is how you kind of, use the concept of signal strength. So maybe when we possibly try to do something called I2C protocols and so on and so forth, you will see there's something called pull-up resistors and weak 1 and a dominant 0 and so on and so forth. So what we do is that whenever we don't want to drive anything, we want to make it as weak 1. So what we do is that we will either, we can choose, right? We can either choose between a weak 1 or we can choose between a pull-up 1. Doesn't really matter, but the strength of these things should be less than the strength of a strong 0. Right? Strong 0 has a strength of 6, weak 1 has strength of 3, or pull 1 has a strength of 5, but both are less than 6. So we can just choose anything. So that is how we kind of work on multiple strengths. So good. I just wanted to make sure that I can share something on this part of it. So okay, I'm gonna wind it up as it's almost time is done. So thank you so much, guys, for attending, and I'll be conducting it out every Thursday. And if you have any questions in between, also make sure you use the SystemVerilog wiki and the discussion section and go and write your questions on it. And as and when we get time, the reviewers or I would answer them. Okay. Sure.
Okay, sir.
Okay, Srinivasa. Thanks,
Sure.
Srinivasa. Thanks, Venkatesh. See you. Bye-bye.
Sure, madam. Thank you. Bye.
Thank you, sir.
Sure. Bye.